and it's talking about the center of a square versus the center of a strip load. So I would say Z is the depth. And I want to plot Z downwards because it's depth. So, and this is then my sigma. And so when Z equals 0, well then I equals infinity. And so you just get sigma equals Q, right, for the square. But then, actually, it says sigma Z as a function of depth, okay, with the same applied stress at the surface. So it doesn't really matter what Q is. So you're really, for any Q, really, if the square and the strip both have the same Q, well, what if you really just plot influence factor? Because you can factor out the Q. They're both the same Q. The only difference would be influence, right?
Yeah.
So when you get Z equals 0, you actually have an influence factor of, well, 100%. Sigma, the induced stress equals Q. Influence equals 100%. So we actually see something like this, 1.0. And you get that right there. If they're the same Q and you're talking about a point directly below the load. Then you see the square if I plot it with depth. So in a spreadsheet, you just put in several different values of Z. Like if you put in 0 and, well, whatever. 1, 2, 3, 4, 5 meters or feet or whatever. It doesn't even really matter. As a matter of fact, why don't you put it in terms of B? That's exactly what they have on those charts we were just looking at. So it is the depth related to whatever's the width of the load. Okay? So if it's a really wide load, then the influence goes deeper. If it's a really narrow load, then the influence is not as deep. But it's the same relationship either way. So let's look at it in terms of Z over B. So it doesn't really matter what B is. So why don't we just say Q equals 1, right? If I said delta sigma equals IQ, but let's just say Q equals 1 unit. Therefore, we're really just talking about I. And if we're talking about depth, but just let's say B equals 1 unit. Because it could, whatever number you want to choose. But if, right, if we're talking about depth, but really we say B equals 1 unit, right, then that's really the same thing. Instead of Z over B, you're really looking at Z. So we're taking induced stress versus depth, but we've just factored it down to really influence factor versus relative depth compared to width. You see what I'm saying? So yeah. The square is going to come down like this. If you plot several values of I versus Z, it's going to come down like this. I don't know the exact shape, but something like that. And it's, you know, eventually it's going to asymptote. Eventually you get deep enough and there is no influence. If that's the square, the square load, the square footing, what do you think the strip would look like relative to that? Well, at Z equals 0, you're still going to have 1.0. You're still going to have 100% influence. But does the stress dissipate faster with depth or slower with depth? Well, a square is just B by B. But a strip load is B wide and really, really, really long. So you expect the strip load to have a greater influence because it actually is covering a bigger area. Right?
Yeah.
So it might come down something like this. The strip load has more influence than the square. because the strip load covers a really long length, even though they're both the same width.
Yeah.
That's what you should expect.
Okay. Yeah, that
Okay,
makes sense. Yeah.
so this is basically the plot that they're looking for.